Well, hello everyone, and welcome to this series of tutorial videos where I am going to talk about subnetting calculations. What I'm going to try to do here is I'm going to try to show you and demonstrate a lot of different types of calculations when it comes to subnetting and different scenarios. So by me creating this series of videos, I hope I will be able to cover most of the cases, and I will be showing you different possible methods to perform these calculations, and it's up to you to choose whatever works and stick with you. So the first video here, we are going to talk about how do we perform simple calculations for a given IP address. So what do we have here? You are giving this IP address that you see here at the top, which is 192.168.139. 76.27. Now what we need to do, we're going to try to figure out what is the network IP address. Now this IP address, it could be for the network, or it could be for a host, it could be a broadcast. We really don't know. So we're going to have to go and we're going to try to figure out what is the network IP address for this given IP address. We're going to try to find what is the first available IP address, what is the last available IP address, what will be the broadcast IP address, and then after that we're going to try to figure out how many usable IP addresses are available within this network. And then after that we're going to try, well, the order here is not necessarily correct. We're going to try to figure out what is the subnet mask. Oh, this is mask, not masked. Let me fix it. Okay. So first thing first, let's start with the network IP address. How would I find out what is the network IP address? The idea here is that you're going to have to first look at the prefix, and the prefix here is 27. 27 simply means you have 27 ones followed by let's say 5 zeros. Now remember here, the prefix here is another way to present the subnet mask. And the subnet mask, if I want to extract the subnet mask from this 27, that simply means, and I'm going to do it here and then erase it, so we're going to have 8 ones followed by 8 ones. Now remember here, I'm talking binary here. And then after that followed by 8 ones. And then followed by 3 ones. And then followed by 5 zeros. Now, again, a subnet mask by itself contains 4 numbers separated with those dots, and the subnet mask basically will be a number of ones in the binary presentation, a number of ones followed by the number of zeros. The number of ones is going to be specified by this 27 here. This is the prefix. And so if you count here, we got 8, we got 8, we got 8, those are 24. And then after that we got 3, so 24, 25, 26, 27. And then since the whole length of the subnet mask should be 32, the rest is simply going to be zeros. So this is my subnet mask. Now my subnet mask, if I want to put it in decimal, and let me do it here, is simply going to be, and let me just type it instead of actually writing it, it's simply going to be 255. This is me converting those 8 ones to decimal. 255 again for those second 8, and then after that we have 255 for the third 8. And now for this number here, I believe this is 224. And if I'm just going to show you how do I do this calculation here really quick. If I just come here and put 1, 2, 4, 8, 16, 32, 64, 128. Now 64 and 120 and 128 and 32 are those representing those ones here, and the rest are zeros. So what we need to do, just have the summation of all these numbers here. So 128 plus 64, that's 192, plus 32, that is 4, and this is 2, and this is 224. So that's the number here. So let's just go ahead and type that. That's 224. So here it is. This is my subnet mask. Okay, sounds and looks good. Let me just try to clean the window that I have here, because I am heading into a direction that I need to actually make it clear. Now, what is the point of the subnet mask and the prefix? Now remember here, both of them are simply representing the same thing. The idea here is that we are going to use the subnet mask and the prefix for one reason and one purpose, which is, the main reason for doing that is to find out the line that separates the network portion from the host portion. So in this case, that line, not in this case, in all the cases, that line is presented at the point where the first one in the subnet mask flips to a 0. So this is the line that separated the network portion from the host portion. Now based on this line, we will use the IP address that we have here to figure out what would be the network IP address. What I need to do, I need to take the IP address as it is and put it in binary here. And then after that, I will show you what to do. Now, to save some time, every time you see one of these octets with the full 8 ones, so this is a case, this is a case, and this is a case, that simply means no change is going to be applied to the corresponding decimal values in the network IP address. So if you, again, this is 192 and this is a 255 that's corresponding to 192. And because this one is 255, so no change is going to be applied to this one. And the same thing is going to be applied for the second one here, and the same thing is going to be applied for the third one. The only change is going to be applied where you don't have 255. In this case, it's just 224. Okay, so I'm going to give you another case after that for a different situation, of course, so let's just focus on the case that we have here. So what this is telling me that those items or those octets, and let me just put a line underneath them, no change is going to be applied to them. The only change is going to be applied is simply going to be applied to this one here, this 76. Okay, so instead of me going through the whole converting of this number into a binary, I'm just going to focus on the part where I need to do the calculations. And this part is simply is this area here. So what I need to do, I need to convert the 76 into binary, and that's what I'm going to be doing here. Now I can, let's just put it in this way. 76, how do you get 76? 76 is simply 64, and let's add to 64, 16. Let's see if that's going to be the case. This is going to be 0, and this is going to be 8. Nope, 16 is not correct. Let's add 8 to it. So I can get 76 from adding 64 to 8. So how much is that going to be? This is going to be 12. And this is going to be 7, so that's 72. And I got 76 here, so I need to add 4 to it. So simply 76 is 64 plus 8 plus 4. That's how you get 76. Now, if I want to put that in binary, that's simply going to be 0, 1, 0, 0, 1, 1, 0, 0. So this here is 76. Again, there's many different ways to do these calculations. In my brain, what I just said, I ask, how do I get 76 out of a combination of these numbers? 1, 2, 4, 8, 16, 32, 64, and 128. And the answer here, since this is 76, so this is definitely not it. And since this is 76, so that simply means 64 is going to be part of it. And then after that, I just, for testing, 32 is going to give me a value that's bigger than 76, so I took it out. 16 is going to give me a value that's greater than 76, so I took it out. Then I added 8. And when I give it 8, it gave me 72. So that's okay. We're going in the right direction. And then after that, I realized you have to add 4 to it to get 76. So that's why I took 4. And that simply means I don't need this, and I don't need this. And if you look here, all these numbers that I put cross on, is 0, 0, and then 4, 8, 32, 16, 32, 64, and 128. So this is my binary representation for 76. So let's just go ahead and put it here. We're going to have 0, 1, 0, and then we follow that with another 0, and then 1, 1, and then 0, 0. Okay? Now remember here, the line that separates the network portion that we have, that we were able to figure out from the subnet mask is the same one that's going to be used to separate, again, the network portion from the host portion in this network IP address. Oh, sorry, this IP address. Now, with that being said, to be able to have or to extract the IP address of the network, we simply have to apply the AND logical operation between those two numbers. And simply AND logical operations will give you a 1 only when both bits are 1. So this is going to be 0, this is going to be 1, this is going to be 0, and the rest are going to be zeros. Another way to get this done, whatever you have after the red line that I have here, just set them to 0 and you'll be fine. And keep whatever you have to the right of that line, set it to 0. Whatever you have to the left, keep it as it is, and you should be good. So with that being said, that simply means if I want to know what is the network IP address, I just have to simply convert those into zeros. So the bottom line, the network IP address is simply going to be 0, 1, 0, 1, 2, 3, 4, 5, and this is it. This is my 76 that I have here. That's an IP address for a machine, and the network IP address is simply going to be whatever you have here, which is 64. Now, with that being said, let's go ahead and put the network IP address for the network, and we're just going to go ahead and answer that question. So let me take this one away. I'll take this one away as well, and this one away, and just keep the subnet mask because we might need it later. Now let's go ahead and answer that question. I'm going to come here and click here. We'll just say net IP equal 192.168.139 dot 64 /27. So that's my network IP address. Okay, now the first available IP address is going to be very simple. It's a straightforward. You just add 1 to whatever the network IP address, and that will be it. So first IP is going to equal 192.168.139 and 65.27. Now, before I jump into the last IP address, let me show you how do we find out what is the broadcast IP address. Now, to find the broadcast IP address, there are two ways to do that. There's a way that I'm going to show you that I think you're going to think it's complicated, and there's an easier way. So whatever works for you, go for it. Now, let's start with the complicated one. The complicated one simply states the following. What do you need to do? You need to take the IP address of the IP address of the network, the one that you have here, the one with the 64, and then draw the line, make sure you have the line that separates the network portion from the host portion, and flip all the zeros that you have after the line into ones, all the zeros you have after the line into ones, and then convert it back to decimal. So let's go ahead and do both of them. And now, again, we're talking about the broadcast IP address. So the 192.168.139, no change is going to be applied to that. We know that for sure. The only part that we know that we should play with is this part here. So I'm just going to come here and put it as 0, 1, 0, and then we got 5 zeros here. And remember, the line that separates the network portion from the host portion is this one. So what I need to do is simply to flip all these zeros to ones, and that will give me the broadcast IP address. Now, I have to convert, of course, this back to decimal, so this is going to be simply 64 plus 31. If you add up those together, 1 plus 2 plus 4 plus 8 plus 16, I know this for sure is 15, and this is 16, so 15, 16, 31. Now put those all together, this is going to be 50, and this is going to be 9, so sorry, 5, 9, so this is 59. That's a broadcast IP address. Okay? So let me just repeat what I said. You take the network IP address, you draw the line that separates the host portion from the network portion. To the right of the host portion, you should have all zeros. To the right of this line, for the host portion, there should be all zeros. You take all these zeros and flip them to 1, convert the whole number back to decimal, you get the broadcast IP address. Now, the new way we can do this is a little bit different, and there's no need to convert any binary numbers to anything. So let me just go ahead here and delete this. Well, just remember here, the broadcast IP address that I calculated here is 192.168.139 95.27. Okay, just put it in your mind. Now let me just clean this section here. Clean this section here. And what I'm going to do, I'm going to show you a different way to get the job done without the need to go through all this. Now, the idea here is very simple. You have this IP address. Let's start with it. 192.168.139.64. And the prefix, you don't have to worry about the prefix. You can write it down here. You don't have to write it, actually. Now, what I'm going to do, I'm going to take this subnet mask as it is. And I'm going to subtract it from 255.255.255.255. Okay, so I subtract this number here from this number here. This is going to produce what we call the wildcard. So 255 minus 255, that will make it 0. 255 minus 255, that will make it 0. 255 minus 255, that will make another 0. 255 minus 224, that should be 31. But again, calculator, just to be 100% sure, 255 minus 224, and that's 31. And here we go, 31. Take this wildcard here and put it here, 0.0.0.31. Add them up together. This is 192, 168, 139, and this will be 95. And that's your broadcast IP address. So you can see here, I didn't have to do any binary. I didn't have to look for the line. I didn't have to do any converting. All I did is I took the subnet mask, the one that you see here, and I subtracted it from 255, 255, 255, 255. It creates what we call a wildcard. Take the wildcard, add it to the network IP address, and you will get your broadcast IP address. So let's go ahead and clear this area here. And let's go ahead and type it again. So I'm going to come here and I'm going to put the broadcast IP address. So broadcast IP is 192.168.139.95.27. Okay, so here we go. Now, the last thing we're going to do here, not the last thing, sorry, the last IP address is simply whatever the broadcast is minus 1. So this is going to be 192.168.139.94 /27, and that is the last IP address. Now, the last thing left here is how many usable IP addresses that we can have. So I'll just type, for example, number of hosts, possible hosts. And to be able to figure that out, the equation is very simple. All you have to do is to figure out how many bits do you have after this line. Now, again, if you don't want to go through binary representation, the answer will be very simple. 32 minus 27. 32 is the length of the subnet mask, which is it's a fixed value, never change, 32, and the prefix that you have, which is 27 that I gave you here. So if you do a subtraction here, it will give you 5, so that's the number of bits you have after the next line. So if you don't want to go through the process of like just writing those ones and writing the line and writing the zeros and counting them, just subtract 27 or whatever the prefix here from 32, and that will give you the number of the host portion. So this 5 here is the host portion. Okay, the equation that we're going to use is very simple. 2 to the power of the host portion minus 2, and that will give you how many hosts you can have. Now that will be simply 2 to the power of 5 minus 2, which equals 32 minus 2, and that is 30. So we can have 30 different hosts in this machine, in this network. So we'll put 30 here, hosts. Now, you may ask a question, why do I have to subtract 2 from the number? The 2 that you're subtracting are 2 special IP addresses that are reserved and you're not allowed to use. And the first one is the network IP address, and the second one is the broadcast IP address. Those IP addresses, like if you're going to try to build a network, and if you try by mistake to assign a machine to this IP address or this IP address, you will get an error, and that will not be acceptable. So this video here just showed you how do you do a simple calculations for a given IP address. I gave you an IP address here with a prefix of 27. In the next video, I'm going to give you an IP address with a prefix of 22, just to show you a case where if the line that you're drawing here is not actually in the first octet or the octet to the right, maybe it's going to be in the middle. So how are you going to handle a situation like that? In the second video, this is what I'm going to be talking about. Thank you for watching. I'll see you guys in a sec.